Here are some more videos from our stair building education series. Let's go ahead and get started with our first video. In this video, I will provide you with a couple of different framing methods that can be used to frame a stair landing that will have a wall underneath it like this one and attached to either one wall or to a corner wall. And this is probably going to be the most common, and that will be where you have a rim joist and you're going to nail into the joist. And if you're using 1.5" construction standard lumber like we're using 2x6 here in the video, then you can probably get away with using 16D nails. And those nails will be used for everything except for the joist hangers most of the time. And in our next example, we are going to have two walls that form a corner, and in this situation the landing will be built basically the same, except you're going to be able to nail this joist to the wall framing, and you will even be able to attach the end of the joist here by using a angled nailing pattern like this one, where the angled nail can go through the joist and then through the other joist and then into the wall framing stud. And of course, if you are using a nailing gun, that's going to be quite easy to do. Next up, let's take a look at the inverted or concealed hanger like we have here. And this is a hanger that does not have flanges on the outside, but has them located on the inside, as you can see here when we take out the joist. So not a bad idea to use something like this, better than nothing. And next up on the list, we have this construction method here that I believe is stronger, and it won't require a lot more materials, just one more 2x4 along with an extension of this joist. Now this idea here seems like it would provide a lot more structural strength because it's sitting on top of a wall here and sitting on top of a framing stud here, and will definitely be something to consider if you're going to have the upper stair stringers sitting on top of this part of the landing. Let's go ahead and zoom in on it here, give you an idea of what we're looking at. End nailing into the ledger here, into the framing stud, and then of course nailing the 2x4 to the framing stud. View from the other side. And if we need it to be a little stronger, we can always make this a doubler and then just have double studs here. And of course this might be required depending upon the weight above that will be transferring from the stringers down to this section of the landing. And if we wanted to make it a little stronger, we could get rid of the doubler and then put a beam in here with a solid post. So another good idea here. The next idea would be to extend the joist like we did with the supporting beam here, and then have it sitting on top of some 2x4s. So this method here is going to require a little more materials, and we will block between the joists instead of using a ledger. And this method right here could save you a few dollars depending upon the price of lumber and the price of building hardware during that period of time. And the joist will end nail into the wall framing studs along with the blocks, and of course you can angle the nails again at either end. Here we're angling them into the block. So again, another idea that will provide you with a stronger landing. Another option would be to frame the landing on top of another wall. So we would be using two walls here. View from the other side, and this would provide you with a sturdy landing, no doubt about it, because we don't have to worry about any hangers loosening up over time. And in our last example, we're going to move the wall and put it on top of the framing plate here so that we won't be using as much lumber. And I would strongly suggest to run at least one of the framing plates all the way through to the next stud to give you a little more support to prevent the wall here from leaning either in or out. But again, this is just another option. You don't have to do it. Just make sure that this is braced and structurally supported so it is not going to move while you're building the stairs. So again, another good idea. And then you would install the sheathing and then just build a wall on top of the landing. And this method here might provide you with, and in my opinion, it would be difficult to figure out if this method is stronger than the previous method because of the way it ties into the wall framing. And even though it might look awesome, I could still see some problems when building the wall on this side and keeping everything straight. I mean, I could just see this right here being built out a little bit, or maybe in about a 1/4 inch, and creating problems for the drywall. But again, that's going to depend upon how much time you spend making sure that this is straight. And something like this could take a little longer to build, meaning that it's going to cost more in labor, and it might be cheaper to just build another wall like this one and put it next to this wall. So with that said, we are at the end of the video. If you learned something, make sure that you hit the thumbs up button. And for those of you who are looking for more information about building any type of stairs, make sure that you visit our website and check out some of our books. In this video, I will provide you with a couple of ideas on how you can create a better connection for your stair stringers if you have a situation like this, and how you can make a repair if you have a situation like this and the stair stringers have cracked or separated from the 4x4, and it's usually not going to be uncommon. If you drive a nail in on each side like this, if you toe nail into the stringer at about the same point on both sides, it's not going to be difficult to imagine this section of the stair stringer chipping off, especially if the grain of the wood is going in this direction. And for those of you who might not understand what I'm talking about, it would be something like this. And of course, if this is the only connection point for the stair stringer to the 4x4, then the stringer would settle down or move down a little bit and separate from the bottom of the 4x4. And of course, this could create a extremely dangerous stairway to walk up and down, because this section of the stairway would be moving, and as it moves, it could put pressure on this stair stringer. And if for whatever reason this one separated, then you would only have one stair stringer holding everything up, and if that one actually separated, then the entire stairway would collapse. So how do we fix something like this? You can do it simply by adding a couple of blocks like this to the floor framing and using a variety of different types of building hardware, screws or nails, to add additional structural reinforcement. And I'm kind of just throwing out a couple of different ideas. You could always use some type of framing hardware like this bracket, to where you might be able to install a lag screw or maybe even a carriage bolt in here, and then install some lag screws or carriage bolts or regular bolts with nuts and washers that would run all the way through and connect the stair stringer to the block. However, I just wouldn't recommend installing too many bolts into a 4x4 like this one, because that could structurally weaken that particular piece of lumber. And another idea would be to use a smaller piece of lumber and maybe another framing anchor. And if you could access the other side, you could always end nail into the block without using any framing hardware. Or you could use some nuts and bolts on this side, again with a larger block and a few more bolts. And in case you haven't noticed, I have 3 different boards here: a larger one, medium-sized one, and a smaller one. And since I'm not a structural engineer, I will let you choose which ones you're going to use and how many framing anchors or nails you're going to put into this thing. Next up, you can raise the stringer back to its original position, and that can usually be done by simply lifting it into place, having someone else help you, or by using some type of a brace. And if you couldn't lift it up that way, you could always use a jack with some type of a post sitting on top of the jack and underneath the stringer. And I will leave that up to you on which method you choose to raise the stringer back into its original position, so that you can fasten it to the block with either some nails, screws, or even by drilling a hole and installing a bolt with a nut and a washer on it. And keep in mind that this might not be strong enough. And if you're looking for something a little stronger, then you might need to install another floor joist. And in this case, we're installing a doubler or 2 joist, and then we're going to be cutting the stringers so that they can attach to the double joist and provide us with a better structural connection. Here is a question that someone just asked a few days ago, and I'm sure they were watching one of my other videos on how you can make these steps a little longer. And I will put a link at the end of the video to that video. But let's go ahead and see what happens when we add 1 inch to the risers, and then I'm going to add 1 inch to the treads. So we're starting with 9-inch treads all the way up and 7.5-inch risers. So each one of the risers is 7.5 inches. And the treads, the depth of the tread is 9 inches. And we're going to add 1 inch to the face of each one of these steps. And I know what you're thinking. I've thought this before myself, is that once you add 1 inch to each step, that you're going to make it a little larger. But that's not going to be the case. As you can see here, we're right back to where we started from, 9 inches. We have 9-inch wide treads. And of course, it makes sense if you think about it. Just have to give it a little thought, or look at this, take a little more time to look at the example here. And of course, the riser height hasn't changed at all. 7.5 inches, we're not affecting the height of the risers or the depth of the treads by adding 1 inch to the front of each one of these steps. However, that's not going to be the case if we add 1 inch to the top of the steps for the entire stairway. So we're going to end up with a taller riser at the bottom and of course a smaller riser at the top. So again, this might not make sense to you right off the bat, but all you got to do is look at the video here, look at the example, and see if it makes more sense. Now, to fix this problem, all we need to do is add the same amount to the top and to the bottom to make all of the risers the same height. In this video, I will try to provide you with some reasons why or why not you might not be able to build a deck over a concrete patio slab. And of course, the biggest problem here would be the concrete footings needed for the posts that are going to be holding up the wood deck. So let's go ahead and get rid of the stairs and build our deck anyway, and take a look at how I would do it if I was going to do something like this. And that would be to provide some type of raised concrete footings. And of course, that can be done a few ways, and I will provide you with that here in a little bit. And there's no reason why you need to remove the concrete patio slab. And I've even built brand new decks with concrete patio slabs under them so that people could clean them a little easier. So let's just say you had a 12-foot deck and a garden hose or a blower, and you wanted to clean the deck. You could just simply blow all of the stuff from one side to the other side. So keep that in mind, and of course that will depend upon the design of the deck. So let's go ahead and take a look at what the building department is going to require, and that will be a concrete footing. However, I won't be able to provide you with the exact dimensions because that might require a structural engineer, but I can tell you that I built plenty of these with 1 foot by 1 foot by 1 foot footings. So that would be a 1 foot square by 1 foot this way, except the 1 foot is going to need to go below the top of the soil, or in areas with frost lines you're going to need to go 12 inches below the frost line. And again, you might need to check with your local building department for more information about that. So not too difficult. You're simply going to create a hole that you're going to be able to fill with concrete for your concrete footings. Now here's the reason why most of you are probably watching this video, and that's to find out if you can just simply attach some type of a post base bracket to the top of the concrete patio slab, and then simply drill a hole into it and use some type of a anchor fastener. And the answer to that question is probably not. Even though I've seen this done before, and I've been to houses where it has been done and I didn't see any problems with it. So I will leave it at that. If you are going to do something like this to support your deck, then you might not ever have any problem structurally with it. And if you were paying attention, I used the word might. Maybe not, but you could also have problems with this, especially when you go to sell your house and there are no building permits to be found for your deck. And that's probably going to lead the building inspector to wonder if there are any concrete footings to support your deck. Next up, let's take a look at a few more options for the concrete footings. And one of those would be to leave the concrete slab as it is, but dig underneath the existing concrete slab so that you have enough room for your new footings. Another option would be to saw cut the concrete slab so that you can dig your holes for the concrete footings. And the last option would be to get a sledgehammer or a jackhammer and simply just break a section of the corner off so that you can pour your concrete footings. And this option might be eliminated depending upon how difficult it is to dig around your soil or underneath the concrete slab. And of course, whether you're going to be able to get to it from two sides or from one side like this over here. And you could always dig this out a little further so that you have access to get the dirt out from underneath here and then use some type of a form board to prevent the concrete from spilling over into the hole or into an area where you're really not going to need any concrete. Now this idea might not work for everyone because you could break a big section of the slab off and that might require you to pour additional concrete. So don't shoot the messenger. I'm just kind of throwing this out there as another alternative. And of course the square hole here, depending upon the location of where the footing is going to be located. For example, in this situation here, it's not located near the edge. Therefore, you wouldn't want to just take a sledgehammer and just beat a big section of the patio slab out. However, I will leave that up to you because it's going to provide you with another option, whether you rent or use a concrete saw or a sledgehammer. And of course, by doing this, you're going to be able to use the hardware that sets in the concrete. And this is going to provide you with a better structural connection. And it's always going to be good to make sure that the hardware is up at least 1/4 of an inch above the concrete slab. And in a situation like this, we removed enough of the concrete so it would be easier to dig. However, on the other side, we didn't. We just removed enough so that we could pour our footing to support the post. And the last suggestion I would like to make is one that I have already made, and that would be to create some type of a raised footing. And some building codes are going to require you to have at least 6 inches here. And that brings us to the end of the video. If you found this information helpful, make sure you let us know by hitting the thumbs up button. And don't forget to check with your local building department to get permits for any modifications to your home, especially if you're planning on selling it in the future, because otherwise you're going to have to get the permits then anyway. In this video, I am going to provide you with some of the problems I ran into when calling for a framing inspection. And one of those things will be the fact that you are not ready for the inspection. Now, don't be confused with a roof sheathing inspection. You don't need to call for a framing inspection if you're not ready, but if you want to cover the house with your roofing paper, then you can call for a roof sheathing inspection. But you can't call for a framing inspection unless all of your windows are in, the fireplace in this case, along with the plumbing, electrical, heating, and air conditioning ducts, and even the exterior doors. And there's a reason why I put this at the front of the video, and that's because I think it's the most important tip I could provide you with in this video. Next on the list, make sure that the plumbers, electricians, or the heating and air conditioning folks haven't drilled any oversized holes or cut any notches in any of the structural lumber that could create a problem for the framing inspection. Now, as we can see here, they have taken what looks to be like a chainsaw, and I've seen this done plenty of times, and cut what appears to be some heavy-duty structural framing plates. And by looking at this piece here looks like it's less than 2 feet wide. And I'm simply basing this off of the 16-inch on-center spacing for the wall framing studs. And something like this might require a fix from the structural engineer, because the first strap is going to go to about here, and then this way 4 feet. And then you're not going to be able to get something from here going this way. So this might require a 6-foot strap. However, I wouldn't want to be the person who nailed the strap on and then had to remove it and then possibly remove some of the framing because it's all split And for some of you, you're probably even thinking, well, why not put a 4-foot strap on this side and then go to the other side of the wall and then put a 4-foot strap on the other side? And to that, I would say clever. But what if the engineer doesn't want that many nails in this section of the wall framing? So again, something to think about before you call for the framing inspection. Next up on the list would be to take the building plans and go around the entire project to make sure that the correct building hardware was used and installed correctly. And for whatever reason, I have a hard time believing that this strap right here was going to work because it's a thinner strap than I'm used to seeing coming off of a 3x plate. And I'm even going to speculate that this strap, even if it was approved, should have been used to connect the two top plates together or moved up. And if you have a 2-story house, you will need to consider the stairway. And for this particular house here, the stairway has a couple of problems with the structural connections. And I'm not going to go into a lot of details about their problems because there's usually not enough information on the building plans to show how all of this stuff connects together. However, I am going to provide you with a couple of building code problems that your building inspector might not like. And one of them will be whether or not your stairs encroach into the minimum distance on a landing, or even, as we will see here in a few seconds, in a hallway. Another thing you should check will be the individual riser height along with the depth of the treads to make sure that they are all the same size. Now, the biggest problem area you're going to run into on a set of stairs is usually going to be at the top or at the bottom steps where the stair builder might have miscalculated something. And if that is the case, then the stairway might need to be removed and rebuilt. Now, as I mentioned earlier, sometimes you're going to have a problem where the stairway is sticking into the minimum width of a hallway. And if that is the case, then the stairway is going to have to be redesigned. And sometimes it's going to be the architect or the engineer's fault because they might have a beam in the way or the architect miscalculated some of the measurements. And I've seen this myself personally. And last but not least, with our stairway, we need to talk about the guardrail, which needs to have a minimum height in most cases of 42 inches. And that would be measured from the top of the finished floor to the top of the guardrail. So not only will it include walls like this that are sitting on top of the floor above, it will also include the walls that are attached to the stairway. Or should I say the walls that would be protecting people from falling off of the stairway. And of course, another problem you could run into will be any changes or modifications made by your construction workers. And even something like this could be a problem for the structural engineer. For example, if he needed a 10-foot overall length on this particular shear wall to provide him with the bare minimum required by the local building department, and you move it 2 inches in or 1.5 inches, then it could be a problem. I'm not suggesting it is going to be a problem, but these are problems that you need to be aware of. And trust me, I've seen plenty of them that have created plenty of problems for the building inspectors. Even something like this, where the structural engineer drew these pieces of building hardware in, and of course they needed to be installed, and somehow created a problem for the stair builder. And I don't think something like this is going to be difficult to fix. However, it might require what I'm going to talk about next, and this is going to depend upon the building inspector, or the mood of the building inspector, or whether the building inspector likes you or not. The fact that they might require some type of paperwork with a stamp on it from the structural engineer for any changes from any modifications or alterations that a construction worker might have made that isn't already on the building plans. Like this toilet here, where it looked like it was in the way of the double joist, and you can see here where the layout marks are on the glue lam beam. So at one time the double joist went through and connected to the beam, but now we'll definitely need the approval of a structural engineer and a detailed drawing of how to make this repair. And And for those of you wondering just exactly how big of a deal something like this is, well, I can tell you from experience that it's usually going to cost somebody a lot of money, and in some cases it can hold the job up. I remember one time working on a project where my dad was building a custom home next to another framing contractor who was building another home, and all of a sudden we didn't see any more work going on. And one day I decided to go over there and just kind of look around and notice that they had notched a glue lam beam for a gas pipe. And then within a few weeks we found out why nobody was working on that job, and I'm guessing it took about a month before people started working on that project again. And of course, another problem you could have is if you use the wrong building materials. I mean, if you don't want to have any problems with the building department, structural engineer, or architect, then why take it upon yourself to make any modifications to anything on the building plans? And another thing, if you're not building a piano, look out for the concrete contractor and move this over a little bit and line your column up with the edge of the concrete. Another concern for using the wrong materials will be to check all of the floor sheathing, roof sheathing, and the wall sheathing, along with your structural shear panel, to make sure that it's all the right size and grade, and make sure that it's all nailed correctly and with the right nails. Another common problem, and even though I can't see it, there might be an anchor bolt here. However, I doubt it because there's a pin here someone drove in. That probably isn't doing anything, especially if it's the same pin that's used for the 2x plates. Just don't forget that you need an anchor bolt located within 12 inches from every framing plate break on the exterior walls. And most of the time, a hold down is not going to replace an anchor bolt. Now, don't ask me why, because it sure seems like it should. Next up on our framing inspection checklist will be any type of fire blocks or draft stopping. And this Stairway provides us with an excellent example of how the fire blocks were installed correctly, even around the landing. Now let's take a look at a fireplace chimney draft stop. And when completed, there will be a round pipe for the chimney coming through this hole with a square piece of metal surrounding it to block off the draft stop. And of course, the draft stops and fire blocks are used to reduce or eliminate the amount of fresh air that can be drawn into a fire and reduce the possibility of a fire entering into the area above the blocks. And even though it doesn't look like this is blocked, there's a good chance it's blocked from below. And you can see a good example of that by looking at the one here going into the ceiling of the second floor. Another problem you could run into, and these aren't always going to be easy to find if you don't know a lot about construction, because it might not always be on the building plans. However, if your building inspector does know a little bit about construction, then it could be a big problem. And that, of course, would be any structural load-bearing beams that are going to be transferring weight from above to the wall framing. Might require more than one trimmer on each side, or even a 4x4 post. And on this particular project, I found about 4 problems like this. And even though this might not be a problem, it seems to be a bigger problem when you have a girder truss sitting over a window or a door header that might be a 4x6 when it really needs to be a 4x12 or larger. So girder trusses are definitely things to look out for whenever you see them sitting over any type of an opening. And of course, the last tip I want to provide you with to keep everyone safe will be to clean up the job site. And I'm not about to suggest this will always help with your inspection, but it's something I made a habit of doing after working for a contractor who swore up and down that it did make a difference. In this video, I will provide you with the lumber sizes for this type of stairway that I think is going to be one of the easiest stairways you can assemble with a small porch. And something like this might work great for a set of stairs where you have a door that opens out instead of in, where the building codes require a landing. And in my opinion anyway, a stairway like this is safer for somebody who's going to be opening and closing a door. However, you would need to check with your local building codes to verify whether or not the stairway will will work in your area. Now, the thing I like about this stairway is that I think it will work great almost anywhere, including areas where it snows and you're dealing with frost line footings. So for example, if you have a 5-foot frost line in the ground and all of your footings need to go below 5 feet and will require a lot of extra work, then a stairway like this that simply sits on top of the ground might be cheaper to build. However, it might not be approved by your local building department. Again, you would need to check with them, because this isn't going to be considered a permanent set of stairs because you're going to be able to move it. Where if a stairway like this had footings, then it's going to be considered permanent and part of the property. And of course, you could rotate this stairway in this direction or in this direction. And since you're going to be able to move this stairway, you can always have it in this direction in the winter and this direction in the summer if that works better for you. So let's go ahead and focus on the stairway, take another look at it here, give you an idea of what it's going to look like when it's done. And I don't imagine this thing is going to weigh very much either. And the thing I like about it is that if the bottom board rots because it's going to be in contact with the ground, then it can easily be replaced if you use screws or some of the building hardware that I'm going to show you here in a few seconds. So let's go ahead and take the stairway apart. All of these components are going to be the same, and you can always change it. You don't have to go with the ones I have here. However, the side pieces might not be able to change. And since most building codes require a 3-foot minimum stairway, this is what we will be using on this particular project. So your 2x4s and your 2x6s for the decking and the stair treads will all be 36 inches or 3 foot. So here we're using a 2x6, 2x6, and a 2x4, and then back here we're going to be using 2x4s. Now let's go ahead and take a look at these side pieces and give you the measurements of what they're going to be. And keep in mind that this is a computer generated model, and because I have never built this, then these measurements could actually be off a little bit. And if they are, please let me know through an email or by leaving a comment in the comment area so that I can make the necessary adjustments. So here we have 5 foot 11.5 inches for those of you who might not be able to see that. And up here we have 5 foot and a half inches or 60.5 inches. And then 4 foot 1.5 or 49.5 inches, and 3 foot 2.5 inches or 38.5 inches. And that will give you your side pieces. Now let's go ahead and put everything together. We're going to start with the bottom section first. And even though I'm showing you that we're using 16D nails, you can use screws also. And I would imagine a 2 3/4 inch or a 3-inch screw would be fine. And since it's going to be outside, make sure that it's at least galvanized or stainless steel coated. And then we can go ahead and assemble the second section. And you can always assemble these sections and then set them on top, or attach this board and then this board and then this one here and then maybe these 3 here. Again, whatever is going to be easier for you to do. Now, you can always attach the upper section to the lower section by angling some screws or nails. And of course, this one here is just to give you an idea of how the screw is angled. Or you can use some type of building hardware like this strap. And if you use screws instead of nails, then you're going to be able to take this apart a lot easier. So if this board needs to be replaced because it rots over a period of time, and you've used screws, it's going to be easy to replace it. Now, for some of you, you're probably thinking, hey, why not use treated lumber? That's fine. And I say go for it if you live in an area where you might have a lot of moisture in the ground for long periods of time. For example, maybe more than 3 months out of the year. And then go ahead and attach the next section. And here we have straps on the outside. And if you connect everything together with straps and you don't attach it any other way, way, then you're going to be able to take this apart in sections a lot easier. And for some of you, you're probably wondering, well, how am I going to clean this area underneath it? And I don't think that's going to be that difficult, because you can just take the stairway and flip it over on its side, clean the area, and then reposition the stairway. Next up, let's go ahead and put the last section on. And of course, that can be attached with the building hardware or the screws. And of course, the building hardware can be attached to the outside or to the inside if you want it to look a little better. And again, I don't think this is going to be a big deal. For example, whether or not the straps are going to be located on the outside or the inside, because you're going to be able to just simply flip the stairway over, start pulling some of these pieces apart if you're using screws, and replace any of the damaged components. In this video, I will try and provide you with at least 2 methods that you might be able to use if you have a stairway in a tight space. And this would include all stairs that would have a small step and a tall riser, making it difficult to walk up and down. So let's go ahead and get started with the first problem you're going to run into, and that would be the fact that the stairs cannot be any longer at the bottom. And that would also apply to the top also. You might have a doorway in the way, you might have a major beam that's coming through in the floor framing, and of course there's probably a good reason why the stairs were designed and built that way to begin with. And I also need to point out that this is the absolute most common question asked on my website and on the YouTube channel also. So the first suggestion I'm going to make will be to build a landing at the bottom of the stairway. And this probably isn't going to be the most popular suggestion, because now you're going to have to step over this landing to get to the other side of the hallway. So let's not shoot the messenger on this one, and keep in mind that these are only design suggestions that you can use if needed. And of course, here's where we would be gaining the extra room by pulling the stairway forward the length of 1 tread. Another suggestion would be to lower this section of the floor to create another step. However, this could also be a problem depending upon the design of the building. In our next example, we will rebuild the entire stairway. And in our first example, we had 13 risers. And in this example here, we have 14 risers. But if you remember, by adding the 2 extra steps here, we are going to remove one of the steps so that we can make the risers a little smaller. And we're going to remove another step so that we can make the treads a little longer. However, another option to keep in mind would be that by adding the 2 extra steps here, you could keep the same riser height and then remove the 2 extra treads from this section to make the treads even wider, making our new treads about 10.5 inches in depth. Next up, for those of you who might need a better picture of what the finished product will look like, let's just go ahead and kind of walk you through it here, where we're going to have a platform in the middle of a hallway if this is the design you're working with, along with the next step that we added by lowering the floor. And then we will take a look at how the step will affect the upper room on either side. And of course, you would need to check with your local building department to see if you could even do this. Now, I couldn't find anything that said you couldn't do something like this as long as the door opens in. So keep that in mind before you make any modifications to your building. And again, this would be a choice you would have to make if you're not currently happy with the design of your stairs. And of course, you would have another option of remodeling the upper floor if that would at all be possible. I mean, keep in mind that most of the problems with stairs that are in tight spaces will be the fact that most of the other rooms in the house will also be smaller, which would make it difficult to remodel any part of the house without removing rooms. And I doubt if you're going to want to take a 3-bedroom house and turn it into a 1-bedroom house just because you're not currently happy with the design of the stairway. Over the years of making videos, I've received quite a few different comments from overly aggressive individuals who don't want to pay for building permits. And I can't argue with them because sometimes these building permits and the fees are ridiculous. For example, one time I remember working on a project in a wealthy neighborhood, and we were installing siding on the front of the house. And for whatever reason, the person I was working for forgot to get building permits to remove and replace the windows. So keep in mind that we're already on the project. The building inspector is not going to have to do any additional work. However, one day the building inspector drove by and seen us replacing the windows and somehow pulled out one of his portable computers and found out that we didn't have permits to replace the windows. So the original permit was for about $1,200 if I remember correctly. And to replace the windows was going to be another $600. Now I do remember that number because I just couldn't believe the amount of money that this homeowner had to spend to replace the siding and a few windows. So if you're one of those people who have went down and purchased a building permit before and think that the prices for these permits are ridiculously out of control, then maybe by building a non-permanent structure like a wood frame deck that is not going to have any concrete footings and will not be attached to your house with a ledger might just save you a few $1,000s. So let's go ahead and get started with our deck here that is not going to be permanently attached to the property by using some type of concrete footings or even a ledger to attach it to the building, because it's going to be sitting directly on the ground. And of course, that's the key reason why you wouldn't need a building permit, because this would be a deck that you could assemble and take apart. So this isn't going to work for a large deck that's going to be about 4 or 5 feet off the ground. It's meant more to be for a small deck that you can sit on the ground and maybe have 1 or 2 steps going up to it. And another thing, I'm not going to provide you with step-by-step instructions on how to assemble this deck, but I am going to provide you with some information on some of the lumber you could use, like for example, a piece of ground-rated pressure-treated lumber, or a piece of lumber that isn't going to deteriorate faster than another piece of lumber. And you could always use smaller or larger pieces of lumber, or have a smaller piece of lumber on the bottom that is going to be pressure treated, and then use a larger piece on the top, or even multiple larger pieces if you need a little more height. And of course, you could attach these pieces together with some type of building hardware, like a strap and some screws. And you could even rotate everything so that the decking can run in the opposite direction. And providing you with another method of construction, you could always rotate this back 90 degrees if you want the decking to go in the opposite direction, or the direction previously shown in the video. And of course, here we just have some beams sitting on top of the ground-rated pressure-treated lumber. Another thing to consider would be whether or not termites are a problem in your area, because most building codes require a 6-inch minimum distance between the ground and construction standard lumber. And this is a problem that could easily be solved by using a 4x6 or a 4x8. And I'm not going to suggest that the ground-rated pressure-treated lumber is going to be termite resistant either. But again, that's going to be another thing to think about. And we can also add to the list that you need to think about how you're going to construct this deck so that it can be adjusted or repaired as easily as possible. And another thing you might need to do will be to bury part of the pressure-treated lumber in the ground, or use a system that's going to use smaller beams. And something like this might require more structural supporting beams running in both directions, like we're looking at in this picture, spread out to support the span of the beams if you need to reduce their size. And again, this is just another method I'm suggesting. And for the grand finale in this video, a method that might provide you with a stronger foundation and a way to prevent moisture from accumulating at the bottom of the lumber. And that would be by building some type of a frame around the deck and then filling it with gravel, and then using the gravel to support your structural beams. I would also suggest to avoid placing anything next to the building. And with these types of framing methods, I don't see why you would need to place anything up against the original building. And the reason for that would be to prevent any moisture from being trapped in this area over a long period of time and eventually creating problems for the building. And another thing you might consider doing will be to drill some type of drainage holes through the frame so that if you do have a lot of water getting into this area, that it can drain out instead of being trapped in this area. And another thing you could always do would be to fill this area with gravel and then avoid using the frame. And again, I will leave that up to you which method you choose to use. And even though I have provided you with pressure treated lumber throughout the entire project, it's not going to be necessary all of the time, and you will be able to use construction standard lumber, especially in areas that have drier climates. And if you are in a drier climate, you might be able to use construction standard lumber throughout the entire project, especially if you're going to be using gravel. And remember, this is a non-permanent structure, and non-permanent structures might not require a building permit. Here is something that could be extremely useful for anyone who is trying to figure out the height of a landing where both the top and the bottom of the stairway are going to have the same amount of steps. And that will be to simply divide the overall height or the total rise of the stairway, or the distance between the top of the lower level and the top of the upper level, and simply divide that number by 2. For example, here we have 4'8", and then we divide this in half, and it's going to give us 2 foot 4 inches. And hopefully that made sense, but if it didn't, let's go ahead and try it in inches. And we're going to add one more step to both the upper and the lower sections of the stairway. So for example, here we have 70 inches, and half of 70 inches is going to be 35 inches. And even though this is basic math, I understand that some of you might not understand how to do this. So let's go ahead and walk you through what it would look like on the calculator. 70 inches, and we're simply going to divide 70 inches by 2, and that's going to give us 35, or half of the distance. And hopefully that made sense. Let's go ahead and take a look at the individual riser height of 7 inches for this stairway. Each one of the risers 7 inches, and of course if we multiply 7 by the amount of risers, 1, 2, 3, 4, 5, we're going to get 35 inches. And since I'm not interested in creating a more complicated process than this, I'm going to go ahead and make this one of the shortest videos I've made in a long time. So let's go ahead and wrap things up by showing you the bottom section of the stairway so that you can see that both the top and the bottom have the same amount of steps. Otherwise, this easy and simple method won't work. In this video, I will answer another question that someone has sent to me, and that will be just how in the heck you can locate the footings for a deck. And even though there are a few different ways, I figured that I would start with one that I think is going to be the easiest. So let's go ahead and get started, and the first thing I want to do is just draw the lines that we're trying to find. And of course that would be the perimeter of the deck. So here we have it on a relatively flat surface. And you need to keep in mind that this isn't going to be the best method if you're on a slope or if you have some type of deformed or twisted ground, because in order for this to work, it will need to be on a relatively flat surface. And the reason why I'm providing you with the outline and the picture of the deck is to provide you with a better idea of what we're doing. So we're trying to find the lines that would represent the perimeter of the decking boards, and not the beams, not the joist, just the decking boards, because this is what we're going to be able to take all of our measurements from. And hopefully that makes sense. Just simply lowered the deck into the ground to create a perimeter, and of course your perimeter is probably going to be different, so keep that in mind. These numbers will be changing unless you're going to build the exact same deck. Next up on the list, we will remove the deck and the measurements, and then we will head over to the building foundation, where we will be placing 2 marks that will represent the width and the location of our deck. And in order for this process to work, we need to have a straight line here. So if the building foundation is not straight, then you will need to come out 6 inches or a foot and then create a straight line that you will be able to work with. And you can do that by placing a piece of lumber down on the ground or by using a string line. But either way, we need to start with a straight line, because the front of the deck is going to be parallel to whatever lines we're using here. And of course, these lines can be drawn on the building foundation or on some part of the house nearest to the ground. And the reason why I'm saying that is that the measurements that we're going to be working with need to be on a level surface. You're not going to want to mark the siding about a foot up above the ground and then come down at an angle to measure any part of this process. You're going to need to be measuring off of a level surface in all directions, or at least as close to a level surface as you possibly can. Next up, we're going to place a board out 12 feet 6 inches. You can simply do this by measuring from the building foundation to the edge of the board. And of course, this board will be parallel to the building foundation. Now, even though we're not going to have these marks here, we're still going to have a parallel board placed approximately where we need it to be. Now, don't worry if this board is over about a foot or two. You can always adjust that later. And for those of you wondering why we might need to move the board over to the right or the left, well, it's because we're going to use the Pythagorean theorem. And that's a simple math formula. A squared plus b squared equals c squared. Now, I do have another video on that. I will put a link here in the video to that video, as well as providing you with an example of how we're going to figure out the hypotenuse of a triangle with a 90-degree angle by using the measurements that we already have for our deck, 11 feet and 12 feet 6 inches. So let's go ahead and break out our trusty calculator and our pre-calculated measurements so that you can observe them. You can pause the video, take a look at them, and see if they make sense while doing your own calculations. Now, the first thing I need to do is break the 12 feet 6 inches and the 11 feet into inches. And you can do this by simply grabbing a tape measure and then pulling it out to 12 foot 6 inches and seeing what's on the tape measure. Then the next step will be to multiply these numbers together. We're going to square them. So if I multiply 150 times 150, I'm going to get 22,500. 150 squared is 22,500. I will clear it, and then we will multiply 132, but I'm not going to square it this time. I'm going to multiply it by 132, and we have 17,424. Then we're simply going to add these two numbers together. So let's go ahead and add 22,500. Brings us 39,924. Then we're simply going to get the square root of that number. And you can do that by pushing this button right here. And you can see that I rounded up the number from here. Since this number is above 5, I just simply rounded it up to a 1. That's where we got 199 inches, 0.81. And if I convert 0.81 to a fraction, it will end up somewhere around 13/16, which will be helpful when we're working with a tape measure. And of course, this measurement here converted to feet would be 16 feet 7 3/16 inches. And that, my friends, is the length of this line right here that we can use to find the intersection point for our square deck platform. And that can simply be done by having somebody hold the end of the tape measure next to the mark on the foundation wall, while you come over here with the other end of the tape measure and then move it along the board until the number you're looking for lines up with the edge of the board. Then you're simply going to mark it at that point. And it doesn't get much simpler than that. because after you have this point here, you're just simply going to measure over 11 feet to mark the other spot for your deck perimeter. And now let's pan out, take a look at the measurement here. And now that we have this measurement here, we need to double check to make sure that everything is square by measuring from this point here to this point here. And if for whatever reason it's off a little bit, then you might have a problem with your square deck, and you're going to have to figure out what that might be. But don't worry about that. I've already made another video, and I will put a link to that video here. And if for whatever reason you can't figure it out, feel free to leave a comment in the comment area or email it to me, and you can get our email address at our website. Now, after you have everything squared, you can put a couple of more boards down that would represent the perimeter of the decking, and then simply measure off of that to find the locations of your footing. So not that difficult, and even if you're off a little bit, that's not going to be a big deal. And when I say a little bit, I would say within a half of an inch, you're probably going to be fine. Your deck's going to look okay. And even in a situation like this, you might be able to use the beams to compensate for any problems. However, I won't be going into detail, and I don't have a video on that one yet. But you can see here where all we need to do is measure from the front of the decking back to the footing, or to the center of the post, or even to the edge of the post. Whatever we need to figure out exactly where the posts are going to be, we can do it from the inside of this little box that we have built. And of course, you're going to want to move the footings away a little bit from the edge of the concrete foundation, because the concrete footings might be in this area. Not going to be all the time, but they might be sticking out into this area, making it difficult for you to install your footing. So that will be another problem that I'm not covering in this video. But for those of you wondering why I moved it back here a little bit, that's the reason why. And of course, the deck joist will cantilever without a problem to cover this area in the back and to cover this area in the front. And with that said, you now have another tool for your tool chest to help you find any parts located within or outside of the perimeter lines you can use to build a square deck. In this video, I am going to provide you with something that I don't see a lot of people doing, but hopefully after you watch this video, you will start doing it. And that will be using your pattern that you cut. You're not always going to be able to lay everything out to where you're going to miss all of the knots or the lumber imperfections with your stair stringer pattern. But again, there's a way around that also, because if you have a pile of lumber, all you need to do is select the best board out of all of them for your pattern. But this isn't always going to be the case if you have only 3 boards to pick from, because that's all you ordered with your lumber load. And of course, if you're hand selecting the lumber, then pick the best pieces of lumber you can find at the lumber yard for your stair stringers. Now, you're not going to have any problem with clear lumber or premium select lumber that doesn't have very many knots in it, or the knots are very small. However, that's not going to be the case if you have a piece of lumber that has cracks on the end and even a few knots. And for those of you who are not familiar with building stairs, what we usually do is cut one stair stringer. We lay it out, we cut it, we double check all the measurements, and then we use it as a pattern. We put it on top of our next piece of lumber and then just simply draw all of the lines that we need to cut all the way around the stringer, remove the pattern, and then cut this piece out. And then we will have 3 or 4, however many stringers we need to build our stairs. Now, this is something I see a lot of people doing, and that's either they order the smallest pieces of lumber they can to save money or maximize profits, or you are not worried about this breaking. And again, that's not going to be the end of the world if you have a crack that runs up here, and after you cut the stringer, you cut the notches out for your stair stringer, this section breaks off. You can usually just grab some nails or screws and then refasten it, connect it back together. So that is not going to be the end of the world if that does happen most of the time. But that's not the reason why I'm making the video. I'm making the video to provide you with a few ideas you can use to avoid that problem. However, by moving it over a little bit to avoid most of the cracks, you can end up with some problems with the knots. and knots on the corner can break off and of course be difficult to nail through. And the main area you are not going to want to have any knots will be at the bottom or the top where you need to connect it to the other framing members. So what do? It's nice to buy at least 2 foot longer lumber than you're actually going to need, so you have some room to move the stringer back a little bit in either direction to avoid as many knots or cracks as you possibly can. And this is going to be a bigger problem with bigger knots. However, that will not be your last option because you can always flip the board over, flip it upside down, and then try moving the stringer to a desired location to where you can miss most of the knots. Now, I also need to point out that this is not going to be the best location for a big knot, and you might need to move the stringer over a little bit to locate the knot in a section of the stringer where you're going to have more lumber. And this could even be a bigger problem if you have longer treads and taller risers. And hopefully that makes sense. This is a bad area and this is a good area. And you can always move it a little bit in either direction, be right next to the knot, or even come in a little into the knot if you need to avoid other knots. However, this is not going to work all the time. You are going to come to a piece of lumber every once in a while that you are not going to be able to work with. And in my opinion, I wouldn't use it if you didn't have to. And I will end the video at that because I do understand sometimes people are going to order 4 pieces of lumber and they could simply use the worst stair stringer in a place where it will be structurally secured next to a framing wall or sitting on top of a wall somehow to where these knots are not going to be a problem. In this video, I want to talk about something that you hopefully never run into, but I used to run into it a lot when I worked on the track houses in the 1980s and 1990s. And this would have been when architects were drawing the plans with their hands, not with computers. However, it seems to happen every once in a while, and I wanted to make you aware of some of the problems you could run into if you're working on a building where there won't be much leeway for the stairs. And if you have measurements that are right on the money and you can't get an extra inch, then you're going to have a problem if the architect puts a measurement in that is incorrect. And I'm not about to suggest that it would have been done maliciously or on purpose. However, it has been done. I've seen this before. So for those of you who really don't know a lot about building stairs and you're working on small houses and you're going to be dealing with the building department, then you better pay attention, because for a stairway in a building with less than 50 occupants, that's right, 50 people, obviously you're going to have only a few people in your house, right, if it's small, but here are the minimum building code requirements for that type of stairway, and that's going to be 3 foot for the landing, 3 foot for the width of the stairway, and usually going to be 10 inches for the stair treads. But, and this is very important, you will need to check with your local building department to verify those measurements, because your building department might have a 9-inch minimum distance for the stair treads instead of a 10-inch minimum distance. So with that information, you can see here where we are at the bare minimum for this particular stairway. And since all of these measurements here are right on the money, we can get a pretty good idea that this is going to work out. However, this is not going to be the case if you have a smaller measurement here than it should be. So for those of you who are paying attention, you're going to need to double check all of the measurements in between the wall framing and have a pretty good idea what those measurements are going to be after the stairway is finished. Now, this is where it gets tricky because some building inspectors are going to be looking for finished measurements. For example, up here you might not have a problem, because if they put a 1/2-inch sheet of drywall here and then add 3/4 of an inch in carpeting or wood flooring, then you're not going to have a problem. But that's not going to be the case down here when you add a 1/2 inch of drywall, and then come over here and then add 3/4 of an inch of carpeting or finished flooring. So if you are looking for finished measurements, then something like this might need to be a little wider. Next up, let's go ahead and take a look at what the stairway might look like if you build it this way, or even this way where you split the difference in the landing. Or in some cases, you might try to outfox the building inspector by giving them the 3 feet on the bottom and then giving them the 3 feet on the top, but taking it out of the treads. And of course, to make up the 2 inches, you will end up with 9 stair treads at 9.77 inches or 9 3/4 of an inch stair treads. However, with each one of these scenarios that I have just provided you with, none of them are going to work if you have a sharp building inspector or if you're worried about building a stairway that's going to meet local building codes. And this is where it goes back to make sure that you get the building designer involved in it. And if you're the building designer and you end up taking all of the responsibility for doing either one of the previous 3 scenarios I just provided you with, and somebody falls down this stairway, you could be losing everything that you own in a lawsuit. Now, for those of you who might have a difficult time wrapping your mind around what this stairway might look like, then let's go ahead and take a look at it here. And here we have our 3-foot wide stair landing with 10-inch treads going all the way up to the top of a 3-foot landing. And of course, these are probably going to be finished stairway measurements. Now, if I haven't scared you enough by now, there's one more thing I need to point out that might be inaccurate also, and that would be the riser measurements. So if, for example, the building designer has made a mistake horizontally, then what would make you think that they didn't make a mistake vertically? So make sure that you get all of the wall framing measurements along with any of the finished flooring materials on the bottom and the top and throughout the stairway, so that you can make the necessary adjustments and not end up with an unhappy building inspector. So in this video, I am going to run through a few ways you can frame a landing. And these ways, the standard way of framing a landing with joist, which you will see in this video, is going to be the most common used. But figured I would throw out a couple of different ways that you could it might be cheaper to build. You might have some scrap lumber on the project, and who knows, one of these just might work for you. So here we have a method where we are simply just using a couple of different walls. If we were going to use 16 inches on center spacing, then we might need to add a couple of more walls in if the stairway was going to be wider. So this is about a 3-foot wide stairway. The walls spacing in between, I would imagine, would be about 15 inches. This would be fine for 3/4 inch plywood. And here's another method that might work: a wall in the middle and a couple of walls on the outside. The only thing with this is you're going to need to center the stud in here so that you can nail the wall framing in the center to the stud. You could always have the plates overlap too if you needed to. So here we have the top plate overlapping over this wall. We would nail down with a couple of 16D nails to connect all of this together. You could do the same thing here, but I don't really think it'd be necessary. Remember, the plywood is going to tie everything together. When you're nailing the plywood into these top plates, nailing down, you're going to be nailing down into this. The plywood will hold all of this together once it has been nailed. And there's the stairway. Another view of it there. And of course, this is the most common method, where we have the joist sitting on top of the framed walls. And if I was going to say which method would I use, this would probably be it. It is the tried and true method, and I have been using this one for quite some time. And of course, the joist might need to run in the different direction. So you can run the joist in this direction, or you can run the joist in this direction, which you'll see here in a few seconds. Voila, there it is. The joists are running in the other direction. Just don't forget that the grain of the plywood usually runs perpendicular to the joist. And for those of you who don't know, if we have let's just say we have a 4 foot wide by 8 foot piece of plywood, the 8 foot long direction is going to need to run perpendicular to the joist. So you would run the 8 foot long piece in this direction. That would cross over the joist. And again, you can run it in different directions. I've read a lot of stuff on plywood, and I don't want to get carried away in this video on it, but check with the manufacturer to verify the information I am providing you with in the video. Stairway. So again, the preferred method, I would say, from me. Next up on the list, you might run into a situation where you're going to need to use smaller lumber. Now in this situation for this stairway, that is not going to happen. But I figured I would show you a method. I've done this before in tight spaces where I might have had a closet underneath the stairway and underneath the landing. And if that's the case, you might just need to, you could use 2x4, which we have here. And these are spaced 6 inches on center, not 16 inches on center, 6 inches on center. And you might need to check with your the lumber manufacturer to make sure that these distances would be approved for your stairs also. Now here's a method that will work, but might not be approved by your local engineer, and that would simply be to nail a scrap piece of lumber onto the framing studs. And of course this could run full length, and then this would be used instead of a hanger to or a ledger, I should say, to support the joist. And of course you could always toenail the joist into the framing plates for some more strength. So this is probably the stinker on the list, but thought I would throw it out there. You never know. You nail like a 2x8 or a 2x12 underneath here, and you put about 4 nails into the studs, set something on top, nail the plywood off, and the plywood's going to hold all of this stuff in place, and it's probably going to be a pretty strong landing. And again, I'm using 2x4 here. You might want to use 2x6 or 2x8 to whatever will work for the span or the length of your particular landing. And in our last example, you could use top flange hangers. Frame the top plates like this. And another thing you could do, even though I don't have the video suggestion in here, because the plywood, like I said, is going to act as your connector, you could actually lose the top framing plates and use top flange hangers, something like that, to save you a few dollars on your framing. So top flange hangers, again, might be the way to go. The only thing that I don't like about the top flange hangers, and I've had a lot of problems with them, I should say, when we use something like this for panelized roofs, is the fact that they usually stick up a little bit, and when you go to nail everything, you could have a bump in the plywood or the sheathing, and that's not always going to be the preferred method for something where you're trying to create a nice flat landing. So that is it for the video. Here is another helpful stair layout and design video. And again, I'm not going to show you how to build this type of stairway. And even though I might later on create a separate book for a variety of different stairways, if that's the case, I will put a link in here somewhere for that particular book. So in this stairway here, we're just simply going to have 4 steps to a landing, 4 steps to a landing all the way around, and it'll be at 45-degree angles. And here are the measurements to scale if you were going to build the exact same stairway, but you're probably not going to. Yours might be a little wider or a little skinnier, and you might have more steps in it or less steps in it. You could always have 4 steps, 2 steps, something like that if you needed, 3 steps to 2 steps, 3 steps, 2 steps kind of a thing. And let's go ahead and take a look at what it might look like when you are done here. 4 steps up to a landing. Just kind of go work our way around the stairway and you kind of see where it lines up here. These 4 steps are this right here, landing here. And then this step right here would be this one right here. Just kind of go around. Nice looking stairway, probably belongs in some type of a castle there, a little larger than most people are going to need. I believe 13, 14, or 15 steps is going to be the average stairway for a 2-story house with a 8-foot ceiling and 2x12 joists, something like that. Again, to our landing. Just work our way around, landing, 4 steps. And the 6 inches here that you see is the required minimum by the building code. So again, even though I'm showing you how to lay out something like this and give you a kind of an idea of what it would look like, you would need to check with your local building department to verify whether or not you could actually build something like this in your particular area, state, county, or country. Now let me see if I can give you a more detailed idea of how to kind of lay something like this out. First off, I want to point out that each one of these angles is a 45-degree angle. Now a good place to start for this type of stairway, since the measurements are going to be difficult to figure out, will be with the bottom section here. And whatever your tread width is going to be, or depth. And then on each one of these I'm going to add 6 inches because that's what the building code requires. They do not have a measurement for the outside. They do on the inside for an angled step. So I'm using 11-inch treads. So I got 4 treads, 11 inches plus 6 inches, or I should say 44 inches plus 6 inches is going to be 50 inches. And we can always double check that on our original plan to see what the inside measurement was, if that worked out. And the next line you're going to want to draw will be this line here, and it can be longer. As long as you have an eraser or a computer to erase it with. But you're going to come off of this point here. We're not going to worry about this point. This line can be longer when we're drawing the first section here. And then we're going to get the intersection point after we draw this line. Then we're going to draw the steps that we need to create a rectangle. And then we are going to continue the line past, and then we will stop it at the intersecting point. And of course this line can be a little longer here also. And then we will come off of here with our 6 inches. So another 45-degree angle. This line right here is going to be parallel to this line here. And of course this line here will be at a 90-degree angle from this line here also. So these lines will be parallel. These lines will be parallel, and of course these lines will be parallel to this line here. So again, we will draw this line, and it can be longer. We don't have to worry about this. And then we will add our 6 inches and then our 44 inches, and then we will create our rectangle again, and then draw this line, and then wherever it intersects here with this one, then we can erase the edges or delete the lines that are sticking past it to create these corners here. So again, this line can be a little longer, so can this one, or you can stop it just like we did here, where this one would be exactly where we want it. The only thing is, we're not going to know how long this line is going to need to be unless we're going to do some math calculations. So this line right here can run longer or shorter. You're not going to worry about it until you do the next section. And of course you will do the same thing again. 6 inches here, rectangle with your steps, and then draw the line to figure out where it's going to intersect here. And of course the last section here won't be that big of a deal because it's going to be exactly the same as this one here. So the lines right here will all line up with this particular section of the stairway. So this section right here will be an exact duplicate of this one, just kind of flipped around. And as a matter of fact, these sections will be the same, just kind of flipped around also. So anyway, that's it. Again, like I said, I wasn't planning on showing you how to build something like this, but if I get enough comments where quite a few people want to see how this stairway is built, then I will be glad to. In this video, I am going to provide you with 10 things that you need to think about. I'm not going to tell you you have to do any of these. I just want to point out whether or not some of these make any sense and provide you with my opinion on them. So remember, I'm not an engineer. I'm not an architect. However, I have probably built over 1,000 stairways and probably spent about 8 years of my career out of the 40 years I've been doing this stuff, building stairs. So with that said, let's go ahead and get started. First up on the list, I know a lot of architects, this is a standard detail. I can't tell you how many architects use standard details and don't really know why they do. They don't know why they're doing it. It's just a standard detail. They might be able to tell you, hey, here's something I do and here's the reason, but whether or not it makes any sense. And this isn't. I just see no need for it. This just doesn't. It provides us with number 2 on our list, which is going to be an additional separation point. So if you think about it, I would just nail these stringers into the subflooring. Either cut the board all the way across and use double 2-bys, or just have the stringers set on top of the flooring. But with that said, the double separation point I'm talking about is, if you just nail it to the bottom of the stringer to the bottom of the subflooring, that's one separation point. It can actually separate from there. If you have the 2x4 nailed to the top of the subflooring and attached to the subflooring, and then you attach the stringer to the 2x4 kicker here, now you have another separation point. You have an additional point right here where the stringer can separate along with at the bottom. Now here's an example of the line going all the way across so that you don't notch it into the stringers. And again, here you can see where you're going to have an additional separation point. The stringer can separate from the 2x4s. The 2x4s can separate from the wood-framed floor. Number 3 on our list will be some type of floor framing blocks, something to support the stairway or provide the stairway with additional support and means of connecting. You can put additional screws in or nails in the kicker board here or in the stringers. Number 4 on our list will be, you can always use some thicker blocks. That makes sense. A 2x could crack or split, and you're like, wait a minute, I want something a little more heavy duty. Go for it. Number 5 on our list will be connecting the stringers. I'm going to provide you with a couple different examples here. This is actually what I would do, and that would be to toenail the stringers. And you can see you get a nice connection this way. If I just had a nail coming straight up, like a lot of times it's common in wall framing, you just have a nail that goes straight up into the framing, and if anything was going to happen, the stud could actually separate because it's just going to be lifting up. There's not a lot of pressure to prevent it from coming apart, but here you're going to have a little more pressure with this type of nailing here. So let's go ahead and point out that there is no kicker board here. This is how I built a lot of stairs right here. That's what it looks like. It does not look like this. What inspired this video actually was I saw somebody put a kicker board in the back. They had it instead of in the front, they had it in the back of the stringer, and they attached a framing anchor like this to the kicker board. So the kicker board and the stringer had a nice connection like this, but it could still separate from the bottom of the 2x4 in between the top of the plywood, top of the sheathing, and the bottom of the 2x4 kicker, and hopefully that makes sense. And this might be getting a little carried away, but you can always go with some heavy duty hardware if you want to put some hold downs in there. And let's take a look at what the stringer would look like without a block. So if you're just going to drive some 16D nails into the stringer, and you're not going to have a block underneath it, the nails are simply going to go through the plywood. And this isn't going to be that big of a deal. You know, if you have access to the bottom of something like this, grab a hammer and cinch the nails. Just take and bend them to where they're flat with the subflooring, and this is going to provide even a stronger connection. And it might actually produce a stronger connection than the blocks, because now the nails are going to be difficult to pull out. So when you put a little more force on the stringer, you try and lift it up somehow. It's going to take even more force to get it out, because these nails are not going to just slide out real easy. Now let's put our block back in and go to number 6 on the list. Would be some type of pressure blocking, and you can see how this could provide you with some additional support. You can nail it into your blocks below, get a nice solid connection, and then go a little higher on the stringers if you want to nail into the blocks here. And of course you could always end nail. You know, you could drive a nail straight into the side of at least one side of the block before you installed the other block. And of course the pressure blocks would give you, just like the kicker board would, a means to nail the riser to it if you're looking for some more support. Also, having the riser nailed to this, I know a lot of people don't really think about it, but when you put the riser in here, this is going to provide you with some more support, because it's connecting the stringers together. And if the stringers are fastened to the ground and the middle one starts to loosen up, well, the plywood, the riser, OSB, it could actually prevent the stringer from moving because of the structural support that it's providing it with. And I hope that makes sense. Number 7 on my list will be to use a thicker riser with plywood, maybe 1 1/8" plywood, something like that. And then of course number 8 would be to use some type of framing anchors. And again, you can see where you can create a heavy duty connection with all of these components here. Number 9 on my list is going to be adhesive. This seems to be popular. People are using it all over the place. I have never ever used adhesive to connect the bottom of the stair stringer or even the riser to the subflooring, and I've never seen anybody do it either. But so this could be my idea here. I'm going to take some of the credit for it. If not, then I'm probably 10th or 20th or 1000th down the list, and I can live with that. So adhesive, put it everywhere. Put it under your connectors, in between your connectors, squish them in there and hope for the best. Number 10 on the list, construction standard lumber. This could provide you with some benefits, but construction standard lumber does shrink. It can warp, twist, and cup. This is going to be something you're going to have to think about. You know, if you're going to be using construction standard lumber and putting something over it, some type of wood finish, you know, maybe some hard boards or something like that, and they start warping or twisting, it could pop some of this stuff apart. So I am going to leave you with one last tip, and then that'll be it for the video. I did think of, you know, with construction standard lumber, if you were going to use it, you could always go underneath the framing if you had easy access and drive some screws up. You could always attach some type of metal. You know, you could use some hardware, something to, you know, drive the screws through if you're looking for even a stronger connection. But you could drive the screws into the stringer. If you have your kicker board or you have your pressure blocks, you know, screw up from the bottom of the plywood, and that's probably going to give you some additional support. So that's it for the video. I hope it provided you with at least one thing to think about, or one idea. And if it did, then my job was successful. In this video, I am going to provide you with a method that could be referred to as a fail-safe method for creating accurate and precise intersection points for polygons or four-sided, five-sided, six-sided objects. So here we have an eight-sided object. And then we have a center point here, center point here. And then we have the angles coming off to get the intersection points. And the circle provides us with a method to get the intersecting points right where we need them. Because if they're off just a little bit, as I have in this example here, then we could have a problem. So you can use this method to double check your if you're going to build, let's say, a gazebo in the backyard or a eight-sided deck, something like that, and you want to make sure that everything is precise and perfect, because if it's off just a little bit, then you could have problems with your roof, you could have problems with your handrails, and on and on. Now in this example here, I went ahead and moved one of the lines here, so that you can see what I'm talking about, where we have a longer measurement here and a shorter one here. And then this, of course, would be, this number represents what the line should be, the measurement for the outside points. Now, the biggest problem with this is how do you fix something like this? Most carpenters just simply split the difference here and make a point and hope for the best, but that might not always work. Now I want to go to a square, just show you a square. Now a square, you don't really need this method with a square, because you can, you're going to have two parallel lines here. You're going to have a line here that is going to be parallel to the line over here. So if the measurement's off just a little bit, for example, if I measure this from here to here, and I can see that it is a little shorter than 9 feet, then I know I got a problem. So I can simply move it. Now I'm not saying, if I measure this right here, I don't know which line to move. Do I move this one or do I move this one? And most of the time you're going to be able to check that with you. If you just cross measure these, you're going to be able to see which line you need to move. But that isn't going to be the case all the time if you come to something that's going to have more than 4 sides. So let's go ahead and start with a center point. And a center point would be from 2 lines. And of course you can have these lines where they're not going to be perpendicular, but it's going to be nice to have lines that are at a 90-degree angle from each other, like we have here. Draw a circle, whatever your dimensions are going to be, and then you can create your object from that. Here we have a 6-sided object, and of course you can use the degrees to find the intersecting points, and then use the circle to double check those points to make sure that everything is lined up. Because if this happens, and again, you might not be able to see this as easy. And you could actually have something that is all messed up in here. But if you have a circle, it's just not going to happen. The circle is going to provide you with a method that you can use to see where the problem actually is. No problem here. No problem here. Here's the problem. And we can draw a 60-degree angle. That's 6-0. And of course that 60 degrees is going to be from this line here. And this of course would be 60 degrees here. And to find our intersection point. But again, with our line coming across here, if you just drew these lines, you just went ahead and put your 60-degree angles in here, you could end up with a situation like this. It's happened to me plenty of times. But once I have my circle in here, I can see there's a problem. And then I can compensate for it and be done with it. So that's it for the video. The main point I wanted to hammer home, I think I did in the video, is just that the circle is going to provide you with a method to double check these points. And if you can have everything lined up perfectly where you inside the circle, then it's going to make building the rest of the project a lot easier. So starting with a nice polygon, equal sides, correct angles, is just going to, project's going to go fit like a glove. You go to cut your roof rafters, your handrails, other parts, maybe even structural beams, something like that. And they're all the same size and all the angles fit together perfectly. The job's going to go together a lot faster and look a lot better when it is done. In this video, I will answer a question that I received. Someone wanted to know what a stairway would look like at a 45-degree angle. And 45-degree angle is simply going to be nothing more than a diagonal line across a square. So here we have a 10-foot by 10-foot square. And of course, here is our diagonal line. So 45-degree angle, just going to be a diagonal line connecting the corners of a square, not a rectangle. A square is something with equal sides and 90-degree angles for every corner. So a rectangle would be something if you had a 5-foot side, and then this one here would be 8-foot different sides. So it's a square, and 45-degree angle is going to be at both ends. And this is what your stairway is going to look like. And the problem created, of course, from the steps, the tread depth and the riser height is going to be exactly the same on a 45-degree angle, making it a problem, or should I say creating a problem for most of your building codes and local building departments. So here we have the same measurement. If this was going to be 7 inches, this is going to be 7 inches. And don't forget that our riser, the maximum riser height for residential stairway construction is 7 3/4 inches. And that would not work for the tread. The minimum distance for a tread is 10 inches. And that probably won't make the building inspector happy. So again, if you're just looking for a means to get from one place to another, you don't have a choice. Do whatever you want. Use 8-inch steps and 8-inch risers, 10-inch steps and 10-inch risers. Just make sure that you have a handrail there. Remember, this will not be a safe stairway, but you might give you something that you can use. So again, 10 inches by 10 inches, the same measurement for the tread and the riser. And another diagram, I'm going to leave the little lines in here. I just divided this up and divided this up. And here we have the lines for our stair stringer, just to give you an idea. Sometimes a picture is worth 1,000 words, and in this case, here's 1,000 words. This is kind of what your stairway would look like at a 45-degree angle. The depth of the tread and the height of the riser will be exactly the same. So 45-degree angle won't work. I would imagine most stairways are between 30 and 38 degrees, maybe 40 degrees, but 40 degrees could be pushing it. So anyway, I hope it helped. I hope this answered your question. Now you know what a 45-degree stairway looks like. And for those of you who didn't know what a 45-degree angle was, now you know that a 45-degree angle is simply a line that would connect to two sides of a square that were exactly the same measurement with a 90-degree angle. So a square cut in half diagonally is a 45-degree angle and will not make most building inspectors happy. In this video, I will be providing you with a little more construction math, and we're going to figure out the ratio, the percentage, and the degrees at which something like this might be. Now you could use this for driveways, sidewalks, anything actually where you need to figure out what the slope would be in a couple of different forms. And the most common form of slope you're going to be dealing with will be a ratio, and that is because it's the easiest to figure out. So most of the time your building codes and stuff like that are going to be related to that. You're not going to have to figure out the percentage or the degrees, but either way we will take it here and give it a shot and see if it makes sense to you. So here we are starting out with a level, perfectly flat piece of concrete and ground. And we are simply going to raise it 2 inches and use this to do a little bit of math or provide you with a couple of formulas. And again, I'm going to walk you through everything with the calculator. I know a lot of times I find on the internet where they have a formula or they tell you how to do it and you're like, okay, what buttons do I push on the calculator? Well, here I will show you on this particular calculator. In our first example, we are going to be working with the ratio formula. And the first thing you're going to need to do will be to convert the units of measurement to the same. So here we have 4 feet and 2 inches. We need to convert either this to inches or this one to feet. We've got to work with the same units of measurement for a ratio. So we are going to take 4 feet and convert it into inches. There are 12 inches in a foot. We're going to multiply 4 times 12 gives us 48. And then we are going to divide it by a common number. And of course 2 divides into 4 foot, so we're going to use that. But we're going to need to divide both the 48 and the 2 to get our ratio. 48 divided by 2 equals 24. 2 divided by 2 equals 1. The ratio for this would be 1 in 24. 1 to 24. So for every 24 units, which would be inches, it's going to rise 1 inch. And this should make sense to you because 24 is half of 48. And if we have a 2-inch overall rise at the end, then in the very middle we should have half of this number, which would be 1 inch. Now this was an easy do here. Let's go ahead and bring in our calculator, and now we're going to take a number that doesn't really divide evenly into itself. So we're going to have 50 inches instead of 48, and 3, we're going to go up 3 inches instead of 2. Use the same formula here, and we're going to come up with 1 as a ratio of 1 to 16.66. Now, when I'm dividing these, I'm just simply going to put 50 in, divide it by 3. There's our number, 16.66. For those of you who aren't familiar with multiplying and dividing, and I do understand a lot of times I make these videos and I lose people because I'm assuming they know how to do something, and I irritate other people who think that everybody should know how to do something. So meeting you halfway in the middle there. And our next one here, next example, what if we had 11, replace the number 48 by 11, and then 2, and we can see that we have an odd and an even number here. And then divide these numbers up, and we have 5.5. The ratio, of course, would be 1 to 5.5. And of course, the 5.5, since that's half of 11, and our ratio is 1 instead of 2, this kind of makes sense. It goes back to that same thing I just said about in the middle here. If this was 11 inches, then it would be in the center. It would be 5.5 would be our length. So for every 5.5, the length of the run of 5.5 units, and in our case we'd be dealing with inches, it would go up 1 inch, and then since that would be at the end 2 inches. Now if this number changed to 3, then this number would be half of 3, 1.5. for that ratio. So, if it was 11 and 3, it might get a little more confusing because now you're dealing with 2 decimals. But that's just the way it is in figuring out the math. So like I said, most ratios are going to be, you're going to use ratios, but they're going to be even numbers. 1 in 24, 1 in 12. For roofs, you might have 3 in 12, 5 in 12, stuff like that. But the ratio is going to be our most common number used in construction. Now let's take a look at how to create a percentage, convert the rise and run to the same units, divide the rise by the run. So here we're going to have 2 divided by 48, and it's going to give us 0.0166. We can either move the decimal point over 2 places to the right, 1, 2. We can see here how I moved it over. Or you can simply multiply this number by 100 to get a 4.166%. So let's go ahead and do the math on this. 2 divided into 48 equals 0.0416. And then we can simply just move the decimal point over 2 places. Each place that you move it over is a, well, I don't want to say, it would be a tenth, 100th, 1000th, 10,000th, something like that. But if that's too complicated for you, this isn't that difficult. Take this number, multiply it times 100, and you're going to get 4.166, which would be the percentage of that. And just kind of wanted to give you an idea what a percentage would look like in a slope. So if we have 100 units here and 100 units here, and I had a line going from here to here, this would be a 100% slope. But a 100% slope is going to be a 45-degree angle. So this is where, or the ratio would of course be 1 to 1. You would have a 1 to 1 ratio. For every 1 unit you go over, it goes up 1 unit. So if you went over 100 units, it would go up 100 units. So that'd give you a 1 to 1 ratio. So just kind of wanted to draw a square in here to give you an idea. If I was to divide this up, I have this divided up into 4 sections. If we divide 4 into 100, we have 25. This would be 25, 50, and 75, and then 100. So if I had a line going from here to here, and this represented my slope, and I wanted to know what percent that slope would be, not the degrees of that slope, but the percent, then I would just simply do the same thing here. Divide 25 divided by 100, 0.25, move the decimal point over, and I got 25%. So a line from here to here would be 50%, and a line from here would be 75%. And it wouldn't be hard to do the angles on this. So if I had an angle coming up to here, this would be a 45-degree angle. Coming up to here, this would be a 22.5-degree angle, half of the measurement. So that would, if that makes any sense. But now let's go ahead and take a look at the degrees. Now degrees are based off of a circle, and a circle has 360 degrees in it, or 4 90-degree units. So if we were to go from the center of the circle to straight across horizontally and then straight up vertically, we're going to have a 90-degree angle. If we have a square in the center of the circle, and this is our center point, this is going to be 4 90-degree units for the square. So if I was to come off of the center up to here, this would be a 45-degree angle. So I just wanted to give you an idea of what the difference is between the percentages and the degrees. So let's go ahead and get out our calculator and take a look at the degrees. Now this is going to take a little more math here to figure out the degrees. Not that complicated, but it is sometimes to find the inverse tangent on the calculator. And you're simply going to take the basically the percentage number, 2 divided by 48. 2 divided by 48 equals 0.0416. We did this in the last, when we were working on percentages. Now the only difference here is we've got to find the inverse tangent key, and that's going to be located on this particular calculator. And here's the tangent, but we need to click on this to get to the negative or the inverse tangent. And once I click on this, it's going to give me the degrees of that particular slope. 2.38, or you could round it off to 2.39 since that is a 5. So that's it for this video. I hope it makes sense. I'm not going to go into a lot on the degrees. You know, like I said, the ratio formula is the one you're going to use the most in construction. But by now, you should have a pretty good idea what the difference is between degrees, ratio, and a percent or a percentage. In this video, I am going to provide you with a few different ideas for building deck stairs, treads, risers, and some of the connection points and problems you could encounter when building a set of stairs for your deck. So let's go ahead and get started. This is probably the most popular design, and that would be using 2 decking boards. And you could do this with all of the engineered lumber, all of the man-made manufactured lumber instead of wood, or I should say materials instead of wood. But in this case, we're just simply using 2 2x6s here. Has an 1/8 of an inch gap in between it. And one of the boards would have to be ripped if you were going to make it 11 inches. But this isn't going to be the case all the time, because sometimes lumber that you get is going to be a little smaller. This would just all depend upon the stairway. So here is our first design. 2x6, no nosing. There's no overhang on this stairway. No 1-inch nosing, which is common. The second most popular stairway for a deck would be using 2x12s. And in some cases 2x10s, but remember the minimum for a stair, the depth of a stair tread is going to be 10 inches for residential, 11 inches for public stairways. So, and again, you'd have to check with your local building department for that information. Again, this is one you're going to see all over the place. 2x12 treads, maybe leading up to a deck with 2x6. You know, you're rarely going to come to a deck where you're going to have 2x12 decking on it. As a matter of fact, I've never seen one. But I have seen this exact setup right here plenty of times. In this example, we are using 2 different boards to create a different design. And again, this isn't a real popular design, but something that you could consider using. A 2x10 and a 2x4. One of these boards will need to be cut or ripped. You know, in this case, I ripped this one here down to 3 inches. So we have a 9.5 inch wide board and then a 3 inch board with the 1/8 of an inch gap in the center. So just another design. Now we do have a nosing on this one. And you can see it a little better here. However, we don't have something at the top. And this is common. I see this a lot. You know, you have a 1-inch overhang and you come up to a landing and there is no nosing on it. So again, I cannot tell you how many times I have seen this. That is not going to be acceptable. You need to put the nosing on there. No nosing, nosing. And you can do that by simply moving the decking and laying it out accordingly, or just putting a larger board here. If you made a mistake when you have everything even, just get a larger board if you can. I mean, you can really see where something like this is going to become critical if you are using manufactured materials for decking. And, you know, you're only dealing with a 5-inch board or a 7-inch board, and you can't get it in a larger board. That could be a problem. Another thing I need to point out, and without the nosing, you can see how this would not be straight. And of course, a straight edge might provide you with a better idea what I'm talking about. If you took a straight 2x4 or a level straight edge, something like that, set it on top of the stairs, then it should touch each one of the front corners of the treads, or at least be close within 1/8 of an inch kind of a thing, to have a nice straight and safe stairway. So our next design would be 3 boards shaped to create this design, and I think I have 4-inch boards here, maybe 4 1/16 of an inch, to create the 1-inch overhang and the 1/8 of an inch gap that we need for our deck stairs. So another pattern there you can use if you like it. Now, before I provide you with some design ideas with risers, I just kind of wanted to point out a couple of problems you could have by simply adding the risers. So in order to do that, I went ahead and I left the previous treads, or the front tread, in its place where it was. So you can see here, by adding an 1.5-inch riser, we are going to be we're going to be getting rid of our nosing, and of course we might need to readjust our stair tread designs, and the bottom really isn't going to be as big of a problem. When you add a riser to the front, whatever thickness it's going to be, as long as it's the same, you add an 1.5-inch thick riser to the front and then an 1.5-inch riser to the next one, you're still going to have the same distance here. We're still going to end up with 11 inches, which would be the same distance that we would have on our stringer. But that isn't going to be the case at the top. We're going to have to add an additional riser, whatever it is, or readjust the stringer. The width here will need to be cut down. So if we didn't add the riser here, but we added the risers to the rest of the stairway, then we're going to have a step. Our upper step here is going to be 1.5 inches longer, which is going to create a problem. So you're going to need to compensate somehow for your risers, either in the stair stringer, the ledger you're going to use, or in the framing of the deck. And don't forget that the nosing on the decking will also be affected by this. In this example, I went ahead and reduced the length of the stair stringer here. It was 9.5 inches before, reduced it to 8 inches to make everything work. And we have 2x risers, 2x8s that got ripped down to 7.25. We have 7.25-inch treads here, or risers, and 11-inch treads. So the treads would have needed to be 2x12 ripped down to 11 inches, unless you could find some 11-inch lumber. And of course here we have everything is working out nicely. No nosing on this one here. And this has been adjusted accordingly. Now this is another problem I noticed with deck stairs. They don't ever, some of the people don't adjust for the soil level or the grass. I've seen deck builders go in and then they build the deck according to the soil level. And then the homeowner plants grass, and then pretty soon they have a 5-inch step here, or it's not even close to the original design. So keep that in mind when you're planning and designing your stairway, because you could always lower or raise the concrete footing if you need to. And that's what the stairway would look like. And another view of it there. Now here's a design idea I don't see very often, but again, if it works, use it. If you can use a 2x6 for your riser, and it's going to have a gap here, and you're fine with it, go for it. Save a couple dollars on lumber, and if you're going to put a skirt board on the side of it, you would never even see it. So just again, another idea. Next up on the list, instead of a 2x6, you could use a 2x4, as long as the distance here is less than 4 inches. Remember, most building codes will not allow a stairway or the handrail, guardrail system to allow a 4-inch round sphere or ball, basically, to slide through any part of the stairway. So you'd have to check with your local building authorities to verify that information. So just another idea. Now, if you didn't like that idea, maybe you'll like this one here. We'll use a couple of 2x4s for our risers. And if you're using construction standard lumber, this might not be a problem. The manufactured lumber, of course, engineered man-made materials might be a problem, as I mentioned earlier. So 2x4, 7¼ inch riser should work out nicely. 3½ inches, 1/8 of an inch gap, 3½ inches, 1/8 of an inch gap, and you are in business. In our last example, we are going to keep the risers, use the two 2x4s, and then switch the treads to a couple of 2x6s. And what I did here was I just went ahead for the 11 inches. Two 2x6s are going to give you 11 inches. If we add 1/8 of an inch gap and 1/8 of an inch gap, we're going to come out with 11¼ inches. So I just kind of left the 1/4 inch nosing sticking out. Just another idea, an option if you don't want to rip the lumber down. Now, if you're using pressure treated lumber, you're probably not going to want to rip it down because you're going to have a side that would need to be treated, or you could put it up against the back of the tread if you don't want to see it. This idea right here might actually work better for pressure treated lumber, or even the man-made decking where you don't want to cut it and kind of mess up the design if it has a certain amount of grooves or whatever the design is in the step. And of course, I need to point out again that whatever the overhang is here, if it's 1/4 of an inch, 1/2 inch, make sure that you match it above. Here is another video with construction math in it. And of course, this is just another attempt of mine to try to explain what some of these geometric figures are, how you can draw them, and how you can use circles and squares and angles, kind of a thing. And I know that I've already made a few of these videos, and I might make some more in the future, but my goal here is to try and have one of these things, one of these methods, resonate with people. And it's like, I might make a video where 20% of the people get it, and I might make another video and maybe another 30% understand it. So that's just kind of where I'm going at here with my thought process. So let's go ahead and get started. We're going to draw an octagon, and I don't have a square shape here. It's a rectangle, but we are going to have a starting point, and the starting point is going to be 4 lines that are at right angles, kind of a thing. So you would just draw a line down the center and then a line down the center of this. And this isn't hard to do. I actually have another video. I'll put a link here to that. And for those of you who you might not be starting with a square side. If you have a straight line you're starting with, then to make something like this, you can do it with a tape measure most of the time, and maybe even a framing square. So we're going to start there. I'm going to come out 6 feet, draw a line there, and then we're going to draw a circle. So the circle is going to have a 6-foot radius. And then you're just simply going to connect the dots. So this is kind of something we can do as kids. This isn't difficult. We're just going to connect the corners here with some straight lines. And then we are going to draw 4 more lines down the center. So we just need to measure the length of this. And let's just say it's 10 feet. Then we're going to come to 5 feet. Make a mark so that we can draw a line. We're just going to connect the dots across here. So not that difficult. I understand it could be still difficult. For me, I'm looking at it. I understand. I drew everything. Drew it before I made the video. So don't. I know that there are a lot of people that I feel like an idiot if I don't get this. Just bear with me. Watch the video a couple of times and hope it'll make sense eventually. So, and then we're just going to connect the dots again. We're just simply going to connect the dots or the lines here where they meet. So here we have it. There's our octagon. So this really isn't that difficult. Once you see it done, I'm hoping it's not that difficult. There it is, octagon with some circles and some squares. In our second example, I'm simply going to take two squares and I'm going to connect again. We're just connecting the dots with two lines across here. And this might not be practical in the field, but you might be able to, this might be able to help you if you are using some type of software like I have here. And what I'm going to do here is just simply move this square over. And I am going to line it up here. So I have two squares. And then I'm simply going to rotate one 45 degrees. So I'm just going to rotate it 45 degrees. So if we were to line the squares up, you could see where I would have it and I would be turning it. This point here would have been this point here lined up, and then I would turn it clockwise at a 45-degree angle to get this. And once I have this, you can see where the octagon shape is in here. So again, this might not be practical on a out in the field, but you might be able to use it with something like this. Now, in the field, I could see where you could do something like this. You could start with a square. And then if you knew this line was going to be 4 feet, you could always draw this at 4 feet and then draw a 45-degree angle. Measure the length at 4 feet. Draw another 45-degree angle. And you can see here where that would be a 90-degree angle off of this. And then draw another 45-degree angle and then just work your way around. And of course, you could always check the accuracy by drawing a circle around. So again, I don't know how practical something like this is going to be in the field, but it will provide you with another way to draw an octagon in a computer software like we have here. So that's it for the video. I understand these aren't no super awesome, you're going to be sending them all over the internet. They're going to go viral, but again, I'm just trying to throw something out there. If it sticks and it makes sense and you can actually look at something like this and understand the degrees, what degrees we're using, what lines we're using, how they connect, then it's going to, very good chance, is going to help you in the field on your next construction project. Here is another interesting stairway design, and again, not that difficult. It looks complicated, but once I show you the secret here, you should be able to build something like this. I say build something like this. At the very least, design something like this. So what we're going to do is start with drawing a line down the center of our 4 foot by 20 foot rectangle. And then we are going to come back 4 foot. Then we're going to draw a circle, and you can choose whatever circle you want for your stairway, the diameter or the radius. This is going to have a 6 foot diameter and a 3 foot radius, and I came back 4 feet, and it provides us with a starting line right here. And the next step will be to remove the rest of the circle. All we're going to need is the shape of our tread right here. And again, if you use smaller circles, the curve's going to be sharper. You use a wider diameters, maybe a 6 foot diameter, then the shape here is going to be, it would probably be something like this. It's going to be, won't be as round. So next step we're going to do is go back in 1 foot increments, and you can choose whatever increments you want to use depending upon your local building codes. The building code books that we use usually require 10 inches for the minimum step for residential stairs and 11 inches for
other stairs. That would be the minimum tread. So here we went 1 foot just to make sure that we're not going to have a problem. And of course, you would need to check with your local building authorities to make sure you can actually build a set of stairs like this also. The next step will be to draw our next tread. And of course, this is going to be a 3-foot radius. You can simply just draw it from here to here. We don't need to draw an entire circle. And of course, that would apply to this one here also. And we're going back in our 1 foot increments. So this is the way we're going to draw the second one, and we're simply going to work our way down to draw however many treads we need. And there it is. There's our stairway. Here's the top platform, or the second floor, and this would be the lower deck here. Now let's go ahead and get rid of the center line, and now it's starting to look more like a set of stairs. And now let's see what it's going to look like when it is finished. So here I have carpeting with wood risers, basically. That's what it's supposed to look like anyway. And I don't think a stairway like this should be a problem. You should have a problem getting it through your local building department. It's still going to have, the measurement is from face of riser above to face of riser below, or the end of the tread to the back of the tread. And if you have a nosing, of course, it would be from the front of the nosing to the front of the nosing on the next one. So anyway, that's it for this design. Hopefully it makes sense. If it doesn't, feel free to leave some questions in the comment area, and I will answer them as soon as possible.
And thanks for watching. To learn more about home building and repairs, visit us at our website. Also, don't forget to subscribe for more awesome content. See you next time.